Okay, we're going to start organic chemistry. Organic chemistry is a class you would typically take as a sophomore in college. So this is just going to be enough information to get you started if you were to decide to take organic chemistry. Most of the time you would only take organic if you were majoring in something maybe pre-med or maybe majoring in chemistry. If you're majoring in biology, etc., you would take organic chemistry. It's a pretty tough course, so I do recommend that when you decide, or if you decide to take organic, that you are mentally prepared. So I don't know if I recommend it as a freshman in college. Maybe wait to make sure that you know how to do your laundry, etc. So wait till your sophomore year. It won't hurt you to wait at all. So organic chemistry is all about the study of carbon. Carbon loves to bond to four things, and because of that, we can get some really large molecules based on carbon. So we're just going to learn the very, very basics, very simple organic compounds. So one thing we need to remember are our prefixes, and again, we're just going to do 1 through 10. They do go up higher, but if you have forgotten, meth, eth, pro, bute, remember Meredith eats peanut butter, hex, hept, oct, none, and dec. Now they have the A taken off of them because of what we're going to learn. So if you need to pause for a moment and write these prefixes down because you've forgotten, take a second, pause, and write these prefixes. So we're going to begin. So the first thing we're going to talk about are alkanes. Alkanes is something we actually learned in Chem 1 when we did methane, ethane, propane, butane, etc. All those anes that we talked about were alkanes. We just never officially gave them the word alkanes. But what an alkane is means they only have a single bonded carbon in their chain. So therefore we call them saturated. You've heard of saturated, unsaturated fats. Well, saturated is the bad guy. Saturated means that it's making the most bonds that it can, and so there's no double bond or triple bond inside the molecule. So again, if we're talking fats, that is the one that's not as good for you. So an alkane, for example, if we were to doing propane, we would know that propane has 3 carbons, and we took this and we multiplied it by 2, so that's 6, and then we added 2 to it, so we got that. So that's what we've been studying, so C3H8. What we're going to start doing now is drawing those structures out. So it has 3 carbons, so we're going to put them in a chain, such like this. Carbon loves to bond to 4 things, so we're always going to have 4 lines coming off a carbon. And so since it's 3 carbons, then the times 2 is these up and down. So notice the carbon in the middle already has 4, so these are always hydrogens going on here. And so there was propane. Pretty easy. And then we even learned a little bit simpler way to write this. So that's one way, and this is actually the way we're going to be drawing it for the way we're going to do, because I want you to actually see the hydrogens and stuff. When you get to real organic, you will stop drawing the hydrogens, and you will, well, I'll show you what it's going to kind of look like here in a moment. But the simpler way to do this one is say, okay, this carbon has 3 hydrogens connected to it, and then this carbon has 2 hydrogens connected to it, and then this one has 3. This is called the condensed structural formula. This is the structural formula, and this is condensed. So this is another way to draw that structure out. Those hydrogens will never, ever be in the middle of that molecule. The carbons are in the chain in the middle. When you get to real organic, you're going to see things just like this. And that's actually propane, and you're going to be looking at the endings are always carbon, and it's just always understood that hydrogens are connected to it. So you'll be doing just lines and stuff. We're not going to do the lines and stuff because you're not ready for that yet. Okay, so that's an alkane. Well, the thing about an alkane, so let me draw a structure here. If we were drawing hexane, of course it would have 6 carbons. I lose track when I start drawing, so that's going to be a bad part of mine. So in every carbon has those hydrogens. So glad I picked a small molecule to draw. At least it's not a decane. And so notice that we've got, so this is hexane. Very simple. C6H12. But hexane actually has something called an isomer. An isomer is another way to draw the structure. Has the same C6H12 formula, but yet it's not really hexane, and that's where we're going to kind of go with this. So if we were to draw this structure, I don't know why my lines are looking weird. 1, 2, 3, 4, 5. I'm going to come down here. If I were to count up all my hydrogens and count up all my carbons, I would still get C6H12. The problem is this is not a hexane. Because in organic, we stop kind of going with these nice chains, and what happens to our carbons, they start branching off. And if you want to have some fun, just Google organic chemistry, and you'll see some beautiful sites. So this is when we're going to start finding something called the parent chain, also known as, I've seen books call it the LCC, which is the longest carbon chain. The LCC, longest carbon chain. So if I were to, and I would highly recommend a highlighter, if I were trying to find how many carbons were actually all connected to one another in a chain without being broke, I could say, going this way, there's 1, 2, 3, 4, 5. Or some of you may be thinking, well, if we went, I'll make that a little bit chunkier. I could go this, that's not much chunkier though, is it? I could go this way. Can you see there's 1, 2, 3, 4, 5. Still there's only 5 connected. So this is actually some sort of pentane structure. So we're going to go with that. I kind of like, if they're the same number, because you're always wanting to find the longest chain, I like to kind of go with the ones in a line. I think that's a little bit of my OCD. So I'm going to highlight mine in that, going that direction. So there are 5. Antigen. Well, there's got to be something going on with this thing. So I'm going to kind of circle him there. So we've got this other CH3 thing coming off of this chain. And what this is called is an alkyl group. It's a carbon-hydrogen group that is coming off what we call the parent chain, or the longest carbon chain. And so this has 1 carbon. And this is something called an alkyl. It's on them. Here, let me go to my next slide so we can kind of see. Oops, don't know where he went. There he went. An alkyl group is a functional group, or we call it a substituent group, which is something coming off the main chain that has only carbon and hydrogen in it. And so a methyl group is going to, like methane is CH4. Well, a methyl group is going to be CH3. So it's going to look like this, which is what we had going off of that structure there. So that's a methyl group. An ethyl group, well, eth means 2, so it's going to be C2, but it's not going to be the times 2 plus 2. It's actually going to be 5, so it's going to kind of look like this. And usually that is connected to the main chain. Propyl group, you could guess it, is going to have 3 carbons, and it's going to have 7, so it would be a chain of 3 coming off. And these are little side chains that are coming off of our main chain, and this is where the naming starts to get interesting. So that's just going to be, these are called alkyl groups. And so methyl, ethyl, and propyl, they go butanol, etc., and they go bigger. But we're going to say small, so we're only going to deal with methyl, ethyl, and propyl groups. So I'm going to go back to that one page that I had drawn. Let me pull him back down. Okay, can you see that that's a CH3 group? So this is some sort of methyl group coming off something that has 5 carbons. So when you go to name these, you always name them. Your ending will always be your main chain. So this had 5 in it, so this is going to be some sort of pentane. So that's the ending of my, so like the last name. Most important is your last name. And then this is a methyl group. So this is some sort of methyl pentane, and that gets stuck. Ooh, that looks bad. Get stuck on the word. Now I've actually seen it separated and put together. I think the most common is to stick the word onto it unless it gets separated by a number, which we'll talk about in a minute. So this is some sort of methyl pentane, meaning it's got a methyl group stuck onto the pentane group. And this is where organic gets fun. We're going to number our carbon chain. And we unfortunately don't always number from left to right or right to left or up and down. We number so that our groups that are coming off, those functional groups or substituents that are coming off, would be on the lowest carbon. So I don't want to go 1, 2, 3, 4, 5 because that's going to be on carbon number 4. I actually want to number it this way: 1, 2, 3, 4, 5. And this is coming off of carbon number 2. So this is called a 2-methyl pentane. So that is specifically telling me where the methyl group is on this pentane chain. Notice it's still C6H12, so it has the, if we were doing inorganic chemistry, it has the same, formula, C6H12, but the characteristics, the boiling point, the melting point, all those things are going to be different because of the way they will react. And we could go deep. We don't want to go deep, so we'll just move on. So that's an alkane. Let's go to that blank page. Let me do. I have to look at my notes. I've got some drawn out of my notes, but I like to draw them with you guys. That way you could draw with me, and hopefully you are drawing with me. So I'm going to go to another 5 carbon. 1, 2, 3, 4, 5. And I'm going to put some things coming off of it. I will tell you, I'm going to write it like this, but I'll show you another way you can write it if you had to draw it. So there's, hopefully you can see that's a methyl group. And sometimes you can write it like that, so you can a little shortcut it a little bit. That's a lot easier, just be frank. I do want you to draw the hydrogens just because you're getting used to it. I promise in Real Organic you don't have to draw all these blooming hydrogens, but you're still in high school, so you still have to draw these hydrogens for me. So it'll be okay. Just make sure all your carbons have 4 lines going around them. You're going to be good as gold. And hopefully I don't make a mistake as I make this video, because I tend to. So hopefully you recognize that we have our longest chain. So if I take my little highlighter out, I'll go back to yellow. My longest chain is going to be 5 carbons. They're not, again, always into a straight line. I could go this way. But you would see a CH3 stuck off of one of the carbons and a CH3 stuck off. So it really doesn't matter if I go up this way or if I'd gone straight. We would actually end up with the same name. You will learn more in True Organic of some differentiating if they're going up or going down. But again, we're just getting the very, very basics. I just want to give you enough information so that if you walk into organic chemistry that first day, you don't feel like a dummy. Second day, third day, you'll probably feel like a dummy, but that's okay. You'll learn, you'll study. So we'll just go with it this way, going upward. And then hopefully you can see these chains coming off. And so we've got this methyl group and we got this methyl group. So we actually have 2 methyl groups coming off. And so I'm going to number them so that my methyl groups are going to hit the lowest number. And so if I go 1, 2, 3, that would be carbon 3. But if I go 1, 2, it's going to be carbon 2. So I'm going to start it with carbon 2. Okay, and we said how many? There were 5, so this is some sort of pentane. That's our last name part. It is some methyls, but there are 2 methyls. So when there are 2 methyls, we actually say dimethyl to specify that there are 2 methyl groups connected. And now we also have to say what number they're on. They're on number 2 and they're on number 3. So the way you would write this is a 2, 3 dash dimethyl. So when you have more than one number side by side, you put a comma in between. So 2, 3 dimethyl pentane. Isn't Isn't that fun? That's lots of fun. All right, so let's look at another. Oh, I did a really long one on this one. Okay. 1, 2, 3, 4, 5. There we go. Y'all probably would be okay if I shortened it, but since I'm going to make y'all draw it out, I'll draw it out. Okay, and then I wanted to put on this one. There we go. Let me get all these other beautiful little hydrogens up there. Again, I would have drawn these ahead of time and just gone through them, but hopefully you're drawing with me. It does help you to draw with me. Slow me down if you need to. Pause me, back me up, whatever you need to do. That's the luxury of the video. Okay, so I need to find my longest chain. So I'm going to get my highlighter out. I'm going to highlight yellow. So I go 1, 2, 3, 4, 5, 6. Go in this direction. If I go 1, 2, 3, 4, 5, 6, 7, that's my longest chain, my LCC, longest carbon chain. So I got a 7, and hopefully you can see we got this crazy thing coming off of it here. All right. So we said 7, so the prefix for 7 is hept. So this is some sort of heptane. And this is not a methyl group, this is an ethyl group. So this is an ethyl heptane. And now we're going to number. This is 1, 2, 3, 4. 1, 2, 3, 4. So it doesn't really matter which direction I number it. It's going to end up on carbon number 4. So either way, it's going to be a 4-ethyl heptane. Okay. So let me show you one more thing. We're going to complicate this just a little bit. And I'm going to take my eraser out on this name. Okay, and what I'm going to do is on this carbon, might as well pick that one. Doesn't really matter. I'm going to add, and hopefully you can see what I just added. I've added a methyl group. Okay, so I don't think I've got my chain where it'd go any longer, so no, I'm good. So I've got 2 groups. So when you got 2 different groups, the way you do it is you do it alphabetically. So when you get ready to name it, it goes alphabetically. So I have an ethyl group and I have a methyl group, and because I have an ethyl group, ethyl would come before methyl. And they say in the rules, if you had like 2 of them, like dimethyl or trimethyl, you don't use the di or tri for putting them in alphabetical order. So ethyl will always be written before methyl, and then propyl will come after that. So just in case you were curious. So let's see. We said the ethyl group's going to come first, and that was a 4. So this is a 4 dash, and this is the ethyl. And then it's dash, and then this is still on carbon number 4, 4 dash methyl. I always run out of room right next to that there. Whoops. So, isn't that beautiful? 4 ethyl dash 4 methyl heptane. Okay, so there we go. I have a challenge. I have a challenge for you. Oh, actually, before I do a challenge, let's do one more. Let's go. I'm liking the 7s for some reason. 2, 3, 4, 7. If you are drawing this one out with me and you're tired of those hydrogens, it's okay. These are your notes. So just make sure on your quizzes, etc. Okay, I didn't finish that one off. So hopefully, again, you can see. Use the wrong color. That's okay. We'll just switch it up this way. Hopefully you can see that it's got these two methyl groups coming off of it. And when we get ready to number it, it would be 1, 2, 3, 4, 5, 6, 7. 5's not looking too good there. And so we've got 2 of them on carbon number 2. So this would be a 2, 2. So you do say the number twice if there are 2 and they're on the same number. 2, 2, and then it is dash di. This is a methyl, and this would be a heptane. Okay, I wanted to show you if they were on the same carbon where you do say the number twice. It is dimethyl because there are 2 of them. If I wanted to stick another one for the fun of it, like here, why would you do that, Miss Smith? Because it's fun. Okay, I'd stick that one there, and then all of a sudden I would have to change this numbering system. It would not be a dimethyl now, it's a trimethyl, and we would say it's a 2, 2, 4 dash trimethyl heptane. Phew, that is crazy. All right, I have a challenge for you. Let's see what you could do with this. Oh my goodness, it's going to take me a second to draw this guy out. So I'm going to challenge you, and then have you pause, and then see if you can get it. It will take me a second to draw this guy out. This would have been a good one to have already drawn out, but that's okay. I need to start drawing smaller ones. Wouldn't be much of a challenge if it was smaller, though. Almost done. Am I going to put anything crazy on this one? We'll see. Okay. If you want to pause right now and see if you can figure this one out. And then once everyone has had a chance to figure it out, we will name it. So if you need to pause right now, hit pause. Okay. So what we're going to do on this one is we're going to figure out what our longest chain is. There's actually 2 ways to go and you can get a longest chain. But when you try to figure out your longest chain, because you go 1, 2, 3, 4, 5, 6 that way. You can go 1, 2, 3, 4, 5, 6 this way. 1, 2, 3, 4, 5, 6 this way. There's a bunch of ways to get 6. But if you went down this way, you would only have 2 branches coming off, 2 substituents coming off. You want to also pick the longest chain that would have the most things coming off of it. So when you get ready, you wouldn't go this way because then that's going to have this big ugly thing that we, 1, don't know how to name, and 2, it would only have that thing coming off and then this crazy thing coming off here. So I would think going this way, you could go up if you wanted, but again, I like to go straight, and now we're going to see what all these crazy things we've got coming off of it. We've got this thing coming off, we've got this thing coming off, and we've got this thing coming off. These are things, oh, and we got this thing coming off. Almost missed that one. So see how the highlighter just makes that a little bit easier to see, and I would, again, highly recommend the highlighter. So we need a number so that those crazy chains are going to be on the lowest number. Okay, so I could go this way, 1, 2, and I'd have this guy. But if I go 1, 2, do you see that's going to catch these guys being on lower number? So that's actually the preferred. We're going to go this way. That's a crazy looking 6. I think my Bluetooth's having some fits here. Okay, so I've got them numbered, and so I've got a 6, so we know it's going to be a hexane of some sort. I've got some methyl groups and I got an ethyl group. So if I go in alphabetical order, the ethyl group will come first. So we're going to go with 3-ethyl dash. Now we've got 3 of them, so it's going to be a try, and these are both on 2. So this is going to be a 2, 2, 5 dash trimethyl, and then it was 6 again, so this is a hexane. Did you get it? If you did, you're awesome. Okay, awesome, awesome. All right, now we move on. So that was pretty much alkanes. So now we're going to go to something called alkenes. So let me go past that. That was just reviewing the alkyl groups, the methyl, ethyl, and propyl, coming off the main chain. All right, an alkene, you're going to like alkenes, it has at least one double bond in the carbon. So we say that it is unsaturated, meaning it's not making the most of its bonds. It has a double bond somewhere in the structure. It's the same prefixes. You'll never use meth because you can't have a double bond with just one carbon. So hopefully that makes sense. Someone always asks, but you can't have a double bond. You can't double bond to hydrogen because hydrogen only likes to make one bond. So you will never see it with meth. But you will see it with all the others, and they're going to work the same way. And so let's just draw one out. I'm going to start out with some 4 carbons. So draw yourself some 4 carbons. All right, and I'm going to put a double bond here, right there. And so now I'm going to... So when you get to this, notice that there's already 2 bonds here, and there's one, so only one hydrogen will come off that, because you need to keep 4. 1, 2, 3, 4 lines coming off. So before you turn your quizzes in, before you turn your test in, go back and look at your carbons and make sure that you've given it at least 4 lines and that you haven't given it 5. And I hope I don't mess this video up and accidentally do that, but I'm sure I probably will. 1, 2, 3, and so I'm just going to put it there just because it looks nice and balanced out there. And then I'm going to just make this one there. Okay, so this is 4 carbons, and my longest chain is going that way, or the other way, it doesn't really matter. So this is some sort of bute, but instead of being butane, this is actually called butene. Notice the ending has changed to an ene. So enes have a double bond in it. And so when you go to numbering, the double bond has to be in the longest chain. For sure, that's real important. The double bond has to be included in the chain. So if the double bond looks like it's going off somewhere, it has to be in the chain. So you have to count that carbon, so that's important. And you want the double bond to always be on the lowest number. The double bond is more important than those methyl, ethyl, and propyl groups. You're going to find that they're kind of like the least significant of all the groups, and everything else is better and more important than they are. Not that they're not great, but so not that we have a methyl group in here, but if we did, the double bond is the one we want on the lowest number. So that's always going to be important. It really wouldn't matter which way we were to number this one, because 1, 2, 3, 4, or 1, 2, 3, 4. So I'm just going to number it this way. And you always record the number on the lowest carbon. I know 2 and 3 are sharing this double bond, but we only want this number. So you would call this a 2-butene. That lets us know where that double bond starts, and it starts on carbon 2. Okay? So usually we don't necessarily need the numbering system on, definitely don't need it on an ethene because it's always going to be on carbon 1, and you really don't need it on a propane either because it's always going to be on carbon 1 as well. But you will sometimes see it, so again, just let you know, that's just a little side note there. So let's look at this one. And then I'm going to go down. Again, sorry you have to wait for me to draw, but I hope you're drawing with me. So I'm going to put a double bond. Where do I want my double bond? There, looks good. 1, 2, 3, 4. See, I almost put a hydrogen on that one. I do it. I'm guilty of it. Hopefully I'll be careful on your homework and not try that. So this carbon only has 2, so this carbon's going to need a couple more hydrogens going off there. Alright, so when I get ready to name this guy, I could go the longest chain. Could you see longest chain would go, whoops, would go this way, 1, 2, 3, 4, 5, but it's not including my double bond, so I'm not going to name it that direction because that would not include my double bond. So I need that double bond to be in it, so I either need to go 1, 2, 3, 4 or 1, 2, 3, 4. Either way, I'm going to come up with the same structure name. So that double bond has to be included in this. So hopefully you can see we got this thing hanging off of the side. Hopefully you can see that that is an ethyl group coming off the side there. So I'm going to start numbering so that my double bond is the lowest number. So there's 1, there's 2, there's 3, this is 4. So it's some sort of, like it was ago, butene, but it's got a ethyl group. So this is a 2-ethyl, and it is a -3. Oh my goodness, I did not add that. I had another structure up here, so just kidding. Woohoo. I didn't look at my drawing. I had put a methyl group up there, but that's okay. So ours is going to be a 2-ethyl dash. Uh-oh, not a 4. 4 was getting from the fact that it was a butene, and it's a 1-butene. On my drawing, on my worksheet, I had put a methyl group up here, so it was a 3-methyl in there. So the ethyl methyls and all that, so the only difference is you've got that double bond going in it. Okay, another one. So, man, I did another big one. Alright, 1, 2, 3, 4, 5. I think I want to do a 7. Alright, I'm going to put a double bond here. And it's 1, 2, 3, 4, 5. And I want to put a double bond here. Oh my goodness, she has just put 2 double bonds in that structure. I know this might seem overwhelming in the beginning, but you guys will get it, and it's not that hard. Now, real organic, it's a booger, but it's a lot of memorization is what makes organic so hard. Just make sure you get a good teacher because that really, really makes a difference. I would love to go back and take it. I did not have a great teacher. He was very mean, but that's okay. Let's see what we can do. We're going to highlight our chain. We'll go in yellow, and I have 7 of them going on. Hopefully you can see that I've stuck a methyl group here. So I wanted to point out that they've got 2 double bonds, and you have to actually account for 2 double bonds. If there were 3, you would have to account for 3. So this is going to be a little bit crazy, but let's figure out the numbering system. Well, we number this way is going to be on carbon 2. The number this way is going to be on carbon 1, that double bond. So I want to number this direction. So we got it on double bond on carbon 1 and on carbon 5. So 1 and 5. Number 3 is carrying our methyl group. So we're going to start out with our 3-methyl. Okay, then it's a dash, a 1, comma, 5, because there's 2 double bonds. Here's where we go crazy. You ready? It is a hept. Okay, hept, but I didn't put ene. It's a heptadiene. Oh my goodness, what did we just do? it is a heptadiene. You have to put that A in there because you'd run the T and the D together. So if you have more than one, it's a diene. If it were three, it would be a triene. So I guess it would go all the way up, but I don't know that there's four. But anyway, we won't go past tri. So see, does it hopefully logically make sense to you? This is 3. It's methyl. And then we put it on carbon 1, and it was on carbon 5, heptadiene. All right. So now we'll go with an alkyne. Alkyne has at least one triple bond in the group. Triple bond, notice the YNE. Okay. So an alkyne, it works the same way, so we won't spend too much. And it's still, let's do a little bit simple one. 2, 3. Okay, so I've got a 5. I'm going to stick a triple bond in there. Okay, and so when we come over, I stuck a, oops, let me get that off there. I stuck a methyl group there. And here we go. Notice this carbon already has 4 things around it. This one has 4, so in that triple bond, you will not be putting any hydrogens on there. So hopefully we could see our chain. There's 5. Same rules. We always want that triple bond. We want a number so that the triple bond is on the lowest number, not that methyl group. So we don't want that on the lowest. We want that on the lowest. So 1, 2, 3, 4, 5. And so this is a 4 dash. That's a methyl stuck up there. Dash 2, and this is a pent. So this is a 2 dash pent. Instead of an ane, this is an ine. Okay, YNE for triple bonds. So you have anes that are single, enes that are double, and ines that are triple. Okay, works the same way, numbering, etc., all the same stuff. So shouldn't be too bad there. Okay, all right, let's see. Next is going to be our alcohols. Alcohols we've done before. So I'm going to pause right there. Let's see if I can get this thing to pause. Okay, our next type is an alcohol. And an alcohol we've actually learned before, and it contains an OH group. Not a hydroxide, it's actually called a hydroxyl group. The difference between a hydroxide group and a hydroxyl group is the fact that hydroxide would have to be attached to a metal, like sodium hydroxide. So if it's an OH group and it is on a carbon chain, it's actually called a hydroxyl group, and it makes it an alcohol. So we've done alcohols before, and so if we were to do something like this, we've got 5 carbons. We'll just put that OH there. Oops. Oh, we might as well throw one of those in there. Okay. The alcohol group is more important to the chain than the methyl group. Like I said before, that those are the lesser of the importance. So these alcohol is a bigger functional group, so it's going to be more important to the chain. So when we get ready to name that, we are going to number our chain using that that OH group. So if we'll look, our biggest chain is 5, and it's got 2 things coming off. It does have this OH, and it does have a methyl. So when we get ready to number, we're going to go 1, 2, 3, 4, and 5, and so now we can start naming. And so this is a 3-methyl, okay, and then it is dash, that is 2, and for the OH, that's when we do an enol. So we've done propanol and methanol, and so this is 5, so it is 2 dash, and this is a pentanol. So alcohols are really easy. They're going to end in a null, and we've done those before, so that's not really much different. So we take the basically we take the E off, and we put an OL ending is what we're doing instead of the ane ending. Okay, so our next two types is called carbonyl group, and that is going to be a carbon that's going to be double bonded to an oxygen. And I hesitated to teach this because we get deeper, but TC has put a ketone on your final, and then I decided to put an aldehyde. My daughter in pharmacy school said, well, I really need to show you the difference between an aldehyde and a ketone because you can get confused. Not that you're probably going to remember anyway, but at least maybe the more times you see it, the better off you'll be with those. So the difference between those, they both have a carbon with a double bonded oxygen. So you're going to see this thing going on. So the difference is an aldehyde is going to have a hydrogen connected. So you're going to see this guy on the end. And then it'll have carbons maybe connected to its chain, etc. So the way you can remember that is aldehydes with the H have an H in them. Whoa, I don't know what happened there. So let's hit undo for that. It has an H in it there. All right, ketone on the other hand also has that, but the difference is you're going to see them like in the middle of the chain. They're going to have carbons on both sides. So if it's an aldehyde, you're going to see an H on it. If it's a ketone, you're going to see the carbons with it. So as far as how we name them, you're going to take that ane ending that we normally see. You're going to take that E off of it, and for an aldehyde, you're going to change that to an AL ending. For a ketone, you still have that ane ending. You're going to take the E off, and it's going to say 1. Basically, is what it's going to look like. All right, so let's look at a couple of those. Okay, so if we had something like this, and 1, 2, 3, 4, he's good, so this guy needs some more. I wanted to give, let's give another carbon in there. 1, 2, 3, 4. So okay, put a group on that. All right, so if I do my chain, oh, I changed what I was doing. That's okay. All right, so it's got a double bonded oxygen on here. So I know that it's one of those carbonyl groups. So I've got to decide if it's an aldehyde or a ketone. So there's this group. Do you notice that there's 2 carbons on both sides? So this is some sort of ketone, because ketone has the carbons on both sides. So this has 1, 2, 3, 4. So it's a bute. Instead of butane, it's going to be bute, and then we put butanone. And then we can number it. There's 1, 2. So this is a 2-butanone. And of course you can put methyl groups and stuff on it, etc. So you can even get it more complicated because you can have an E in there if we put a double bonded. So they do get much more complicated, but we're going to try to stay pretty simple with this, hopefully. Alright, so let's look at an aldehyde then, the difference being. So we can pretty much play with that structure. Let me do a little undoing here. Well, I'll just redraw. Redraw V, just as easy. Alright, so 1, 2, 3. Throw another one on him. Here we go. Alright, so we still have a butte. And then it's AN, but we're not going to put the E because it's got this thing on it. And if you'll notice that one of these things that's connected to this carbon is a hydrogen. And so this is when we do an AL. And on butanol, and honestly, and this is the IUPAC naming system. When you go off to college, you'll actually learn more formal, or I should say common names for them. Like dihydrogen monoxide we call water, so you'll learn some common names for them, but where I'm teaching you the IUPAC formal name for it. So on the aldehydes, the AL, you actually don't have to put a numbering system because the only time where there ever will be number 1 spot. So you won't have to put the 1 with them. So if you see the double bonded oxygen on the first carbon, because it's going to have a hydrogen connected off of it, you know that it's going to have to be an aldehyde. If that double bonded oxygen is somewhere in the middle of the chain, and you know you're dealing with a ketone, and that's when you have the ONE ending on there. And I had erased that one, and then that one is the one that requires a numbering because we know it's not going to be on carbon number 1. Okay, so hopefully this makes a little sense to you. You know, I will be uploading this video, and so you can watch it as many times as you need to. And we have a practice worksheet, so it's not as bad. So we remember the ANES endings. Those were single bonds, and they are just the carbons. And then we had the ENES, and that had a double bond in the carbon, double bond or bonds. And then the INES had a triple bond. So these are the endings. And then we had the alcohols, and the alcohols are going to have that nol ending, so they're going to look like a nol, so methanol, and those are the ones that have the OH. And then you have your ketones, and your ketones are the ones that have that anone ending, and they're going to have that double bonded oxygen, but the key to that is the carbons are connected to some other carbons, and that's a ketone. This one's a ketone, and this one's an alcohol. And then you have the aldehydes, and the aldehydes are going to have the anal ending. Looks like anal, but it once you put that prefix, it looks a little bit better. And then it's the one where it's going to have that hydrogen on there, but it still has that double bonded oxygen, and that is an aldehyde. Oh, really misspelled that word. Eraser. Oh, nope, just looked. Oh, yep. Aldehyde. Put an R in there for some reason. Okay, and then you have your, basically the only functional groups that we're kind of dealing with are your methyls. And then you had your ethyl. I am having a spelling difficulty. Your ethyl, that's a T2H5 if we shorten it, and then we have the propyl. And that's C3H7 if we shorten it. With these two being much, much more common than the propyl. Well, I'm sure the propyl is very common if you get into bigger structures. Again, we're going to stay nice and simple. And we are going to draw our hydrogens to just kind of get used to it. And remember that your carbon always needs to have those 4 bonds. If we had a simple little methane, it would look like that. So I know you don't really want to draw your hydrogens, but we're going to draw our hydrogens. You can shorten it if you want to do it like that. If you were doing an ethyl group, that's okay, and you can shorten the other. But all right, So this is your little intro to organic, and hopefully it makes sense to you. So